Okay, practice test here. Hopefully that will be ready for a test tomorrow if we take the practice test here and use this worksheet as a reference during the test. And I want to show you with this PowerPoint how, if you don't remember one of the shortcuts, synthetic division will still come to your rescue. All right, so let's look at one of each. Of course, if you recognize this, you'll say, hey, 125 is a perfect cube. It's 5 to the third power, and you recognize 15 as being 5 times 3. You go, hey, this is just x minus 5 quantity cubed. Of course, it's got to be a negative because you see a negative 125 at the end. If you don't recognize it as being a perfect cube, I can set up with synthetic division, and if I guess 5, drop, multiply, add, multiply, add, multiply, add. Oh my goodness, no remainder. So I know x minus 5 is a factor, and I'm left with x squared minus 10x plus 25. Sure enough, if I factor that, I will get x minus 5 times x minus 5 times x minus 5, which of course is x minus 5 to the third power. So if I don't recognize the shortcut from Pascal's triangle, synthetic division will still work for me. And again, another one that doesn't require any step-by-step work, you say, hey, it's a difference of cubes. This is a u to the third minus v to the third. All right, so u minus v becomes x minus 5. U squared will be x squared plus u times v. Well, x times 5, we'll write it as 5x plus v squared, so plus 25. Right, because we started with x to the third minus 5 to the third. If you don't recognize that and you set up synthetic division, notice I need some placeholders. So I got a 0x squared and a 0x. If I guess 5 and I go through the synthetic division, I of course have no remainder. So x minus 5 is one factor. X squared plus 5x plus 25 is the rest of it. And that will not factor, right? I cannot think of two numbers that multiply to be positive 25, but add up to 5. So that won't factor any further. Of course, if it would factor further, they would have given us a better equation for the u to the third minus v to the third. And then the other shortcut we learned was factor by grouping. I'm like, hey, common factor from the first two terms is x squared. Leaves me x plus 3. Common factor from terms 3 and 4 is a negative 4. Leaves me x plus 3. Since those x plus 3's match, I know I can use the distributive property. X plus 3 is one factor. X squared minus 4 is the other factor. And of course, x squared minus 4 will continue to factor. X minus 2, x plus 2. If I don't recognize that as factor by grouping, I can try positive 2. This will work quite nicely with synthetic division. I also could have tried negative 2 or negative 3, as those would also be roots. But the positive 2 tells me that one of the factors is x minus 2. I'm left with 1, 5, 6, in other words, 1x squared plus 5x plus 6. That, of course, factors into x plus 2 times x plus 3. And, of course, I get the same answer with synthetic division that I would have done with factor by grouping. So our goal here is to be able to factor polynomials that are third power. In other words, it'll be x to the third as the largest exponent.